Hi grade 8, welcome back to another one of our video lessons. So today we're going to continue with more geometry. So from the last lesson we left off on exercise 11.2, which you guys had to do. You had to classify these triangles and solve for the unknowns, which were, well, x, y's and whatever they were. Okay. Right guys, so now we're going to move on to the next section, which is identify and classify quadrilaterals. Okay. So firstly, a quadrilateral is a plane figure that has four straight lines joining together to form four vertices. Okay, so this is not saying anything about the sides being equal or parallel or any angles or anything like that. A quadrilateral is simply a figure with four straight lines joined together to make four vertices. Whether those lines are the same size or not, whether there's 90-degree or not, that we don't know. Okay, and we're going to go through different quadrilaterals and we'll see what they are. Okay, right, so a vertex is a point at which two straight lines meet to form an angle. Quadrilaterals can be identified by the sizes of their angles and the lengths of their sides. Okay, so we're going to use the similar approach as we did in triangles to identify our quadrilaterals. Okay, so let's look at the first example or worked example on page 117. So if you draw a diagonal, you divide a quadrilateral into two triangles. So you can use your knowledge of triangles to explore the properties of the angles of different quadrilaterals. Okay, so remember when we went back to drawing a quadrilateral, okay, we used the method of two triangles to get the other side of the quadrilateral. So here we're going to do the same thing. We're going to divide our quad into two triangles and use that in order to identify what it is. Right, so let's look at the example. They say ABCD is a quadrilateral, meaning that it's just a four-sided figure. Diagonal AC is drawn in. Angle B is 96 degrees and angle BCA equals to CAD, which is 42 degrees. Okay, so cool. Let's draw this this question or this diagram first. So we have the quadrilateral, okay, and we call it A, B, C, D, okay. Then they draw in AC, okay, there it is. And then let's look at the info. Angle B is 96 degrees. And BCA equals CAD, which is 42. Okay, so BCA, this is 42 degrees. Okay. And CAD, that is also 42 degrees. Okay, great. Now, number one, calculate with reasons the value of x. Okay, so we have x over there and we have y over there. Okay, they have marked that these two sides are the same. We need to understand why they are the same if they are the same. Okay, so I'll leave that out for now just to see how we get there. Okay, so what we notice here is that we have a Z forming over here, right? And we have an angle of 42 degrees and another angle of 42 degrees. So that means that the grade 12s are distracting me a little bit. So that means that if the angles are the same, it means that these two lines are parallel. Okay, and this is in our case. Okay, so okay guys, let's carry on. Sorry about that. The matrix did want something. Anyway, right, so what we found is that we have these two parallel lines because we have the same angle over here, right? Remember, we're using now alt angles in reverse, okay? So that we can get from there. Whether it's relevant or not, we'll see, but that's what I've noticed. Right, so now they want us to find angle X, okay? X is over here. So how much is that angle X? Well, we have 96, we have 42, so we can easily get X. Okay, so let's write that down. I'll do it over here. So we have X plus 96 degrees plus 42 degrees equals to 180 degrees. What is my reason? The reason is angles sum of triangle. Okay, and that is enough for us to understand what's going on. So now what we have to do is solve for x. So x equals, we're going to take the 96 and the 42 to the other side. Let me just move the camera a bit so you can see. There we go. Alright, so 96 and 42 go to the other side. So x equals 180 minus 96 minus 42. And that will give us an answer of x is 42 degrees. Okay, so what we find is that this x is also 42 degrees. Okay, there it is. Cool. Right, well now, since these two lines are parallel, those both are 42. Let's see what else they want. So number 2, classify a triangle ABC and explain your answer. Okay, so let's look at triangle ABC. What kind of triangle is it? Well, we can see that there's two of the same angles, which means these two sides have to be the same. Okay, so that side equals to that side because our angles are opposite. So I'm just wondering if that's a mistake in the textbook because they've made this side and this side equal. Okay, and that could be their fault. Okay, so we have that and we're going to classify it. So what is the biggest angle that we have here? It is 96. 96 is an obtuse angle, which means that it is an obtuse angled isosceles triangle. Okay, obtuse angled isosceles triangle. Let's see. Yes, it is. Okay. The reasons, you have to tell me why you're saying it's an obtuse angled isosceles triangle. So the two reasons, obtuse angle, you have to show me which angle is greater than 90. So you're going to say, okay, so I'll answer triangle ABC is an obtuse angled isosceles triangle. Okay, so you can even call it isos triangle. Okay, as an abbreviation. Right, why am I saying that? Well, firstly, angle B is greater than 90. Okay. And why is it an isosceles triangle? Well, we have angle A, or rather, let's not call it angle A, let's call it properly angle BAC. So angle BAC equals to angle BCA. Okay. Therefore, we can say that AB equals to BC. Okay. There it is. Okay. Right, so the last line just says AB equals to BC because of the two angles are the same. All right, cool. Let's continue. Number 3, calculate with reasons the value of y. Okay. Well, here's my y. We need to calculate the value of y. Let's now think what we can use. So the parallel lines give us alt angles. Okay. We know that these two lines are parallel. So what can we say about? Well, think about it. What results can we use? We can use co-interior angles, right? So that plus that will give us 180, and that plus that should give us 180 as well. But we don't know this angle over here, so that doesn't really help us. Okay. I feel like they forgot to tell us that these two sides are equal because I feel like we are missing a piece of information. Yeah, we definitely are missing a piece of information. Let's see what they tell us. For number 3, ACD equals to 42 degrees. Why is that? AD equals to AD equals to CD. AD equals to CD. Okay, you see, that reason in number 3 in answers, AD equals to CD, I don't see where they got that from, okay, because they never mentioned that in the beginning of our question, okay. So what we can do is we can say that, well, that also equals to that, okay. And if these two are equal, that means opposite angles are equal. That means this is also 42 degrees, okay. And if, well, we can use the parallel lines, or we can use angles of triangles to solve this thing. So what I mean is that we could use co-interior over here, so that plus that equals to 180, or we can use that we have angles of triangle add up to 180, which would give us exactly the same answer. So what they do there is they say ACD is 42 degrees, great, therefore y is 96. So they use sum of triangle ABC, so they add that, and that together. Okay. Right, number 4, classify triangle ADC and explain your answer. Okay, triangle ADC. Okay, what kind of triangle is this? This was 96. Okay, well, this is also an obtuse angled isosceles triangle because these two sides are the same. There we have an obtuse angle. So really these two triangles are exactly the same the way they've been done in this question. Okay, let's see what they call it. Triangle ADC is an obtuse angled isosceles triangle. Great. Same justification. Tell me which angle is greater than 0 and which sides are the same. Okay. Number 5, show by calculation that the sum of the interior angles of ABCD is 360 degrees. Okay guys, that's another result that we're going to learn, that if we have a quadrilateral, okay, whichever one it is, the interior 4 angles on the inside, if we add them all together, they'll always be equal to 360 degrees. Okay, so with the triangle it's 180, with the quadrilateral it is 360. Okay, so they want us to verify that. Okay, so what we're going to do is we're going to add up all of these angles together and we're going to show that it equals to 360. Okay, so pretty much what they've done, number 5, they list the angles in terms of their letters and then they substitute the values and give me the answer. Okay. Right guys, that was the worked example. Let's look at the next page. So here we have a summary of the angle properties of quadrilaterals. So I'm going to run through the various quadrilaterals that we have here. We'll revise them. You've met them last year already. And we're going to look at the next worked example, and you guys are going to do exercise 11.3. Okay. So a summary of the angle properties of quadrilaterals. The angles of the quadrilateral add up to 360 degrees. Okay, so any quad, if we add all the angles, like in the diagram, A plus B plus C plus D equals to 360 degrees. Okay. A rectangle has 4 equal angles. They are all 90. Remember, a rectangle is a special type of a quadrilateral where the angles are all 90 degrees and the two opposite sides are equal and these two opposite sides are equal as well. Okay. So that's a rectangle. Also, the sides are parallel. A square has 4 equal angles and they are all 90 degrees. Okay, so the square, remember, all sides are equal, all angles are equal, and they are equal to 90. Okay. The next one is a parallelogram that has 2 pairs of equal angles. The equal angles are opposite each other. Alright, so a parallelogram is almost like a rectangle, but it is slanted. Okay, so I'll give you an example. So a parallelogram has parallel sides and it doesn't have 90-degree angles. Okay, so it looks something like that. If we give it 90-degree angles, we're going to get a rectangle. So a parallelogram is just a rectangle that's been kind of put on its side a little bit. Similarly, we have a square, and if we tilt that square over a little bit, we're going to get a rhombus. Okay, so the same thing is happening. So the properties here is that this side is parallel to that. These two sides are also parallel. That equals to that, and that equals to that. Also, opposite sides, or opposite angles of a parallelogram equal to each other. So this angle here equals to that angle over there, and this angle equals to that angle over there. Okay. So that's a parallelogram. A kite has one pair of equal angles. The equal angles are opposite each other. They are at the point where the unequal sides meet. Okay, let me draw that for you. So we have a kite that looks like that. Okay, so they say a kite has a pair of opposite angles, and those opposite angles are where the two unequal sides meet. Okay, you know that feeling when you're about to sneeze and it goes away? Just had that. Anyway, so this side equals to that side, and this side equals to that side. Where the two unequal sides meet, there and there, we have same angles. Okay, so that angle equals to that. The sides are the same, and that's it. Okay. And then, obviously, in a kite, we can also join these two lines together, and they will always cross at 90 degrees. Okay. Right, let's continue. We have a rhombus that has both pairs of opposite angles equal. Okay, so a rhombus is a very similar to parallelogram, is that the only difference is that all the sides are equal and opposite angles are equal in a rhombus. Okay, and then the last one is a trapezium, and the trapezium has one pair of opposite sides equal. Okay, so only one pair of opposite sides, not equal, parallel. Okay, so we have a line, we have another line that's parallel, and that's that. Okay, so the only property here is that it's a quadrilateral with two parallel sides, and that's it, or one pair of parallel sides. Okay. Right, now if we have parallel sides, remember this angle plus this angle will equal to 180, and that plus that will also equal to 180. And if we add everything, it will be obviously 360. Okay. Right, guys, that takes us to the next example, which is on page 119. So PQRS is a quadrilateral. It is not drawn according to scale. So that's part of the trick of the quadrilateral questions, that I won't draw it like a perfect rectangle where you're like, oh, it's a rectangle. I'm going to draw it as a four-sided shape that doesn't have anything that looks the same. But the info might say that, oh, actually these two sides are the same, which you need to prove to me. Okay. So PQRS is a quadrilateral. It is not drawn according to scale. Angle P equals 2x, angle Q is 80, angle R is x plus 50, and angle S is x plus 30. Number one, sorry guys, I need to take a little break. Okay guys, sorry about that. Right, so let's continue. So we have a trapezium. We're on the worked example. So we have those four different angles. Number one, calculate with reasons the value of x. Okay, let me quickly draw this thing. So we have a quadrilateral that says 2x, 80 degrees, x plus 50, and x plus 30. Okay. So now, and we have P, Q, R, S. Okay, cool. So we need to solve for x, giving all the reasons. Okay, well, the only thing we can do here is use the theorem or theory that says that the interior angles of a quadrilateral add up to 360 degrees, because that's all the info that we have. We don't have any parallel lines, we don't have any triangles, we don't have anything else to go on. Okay. Right, so let's do that. So what we're going to say is that 2x plus x plus 30 plus 80 plus x plus 50 equals to 360 degrees. Okay, why are we saying that? Well, the reason is angle sum quad equals 360 degrees. Angles sum quad. Sorry guys, my phone is ringing. Okay guys, sorry about that again. Hopefully we won't have any more interruptions. Right, so we've got our equation. Let's solve it quickly. So we have 2x plus x, that's 3x, plus another x, that's 4x, which equals to 360. And then we're going to take these numbers and take them all to the other side. So we have 30 plus 80 is 110, plus 50 is 160. We take it to the other side and it becomes minus 160. Okay? So 4x equals to 360 minus 160 is 200. Okay, now remember we want just x, so we divide by 4, and we get that x equals to 200 divided by 4 is 50 degrees. Okay, right guys, so that's how we solve that. And number 2, classify this quadrilateral based on its angles. Okay, so now we know what x is, we can fill in this information. So 2x is 100 degrees. Okay, x plus 50, well, that's also 100 degrees. Okay, x plus 30, that's going to give us 80 degrees. Okay, so what kind of quadrilateral do we have? We have two pairs of opposite angles that are the same. Okay, so could this be a rectangle? No, because the angles are not 90. So we know it's a slanted shape. But which shape has two opposite pairs of angles the same? The answer, it's a parallelogram. Okay, or it could be a rhombus. Okay, so either parallelogram or a rhombus, but we can't really determine which one it is because we don't know the sides. Okay, we were not given anything about the sides. So if we had to conclude and pick one, I would say it's a parallelogram. Okay, because if I say it's a rhombus, I have no proof saying the sides are all the same. So I can't call it a rhombus, I have to call it a parallelogram. Okay, so is that right? Yes, PQR is a parallelogram. Cool guys, so that is the worked example. I want you to do exercise 11.3 for homework. It's only 4 questions and it's looking at the same idea as we've done in the worked example. Okay, cool guys, thank you, and I hope you enjoyed the lesson. I will see you next time.